Hey folks, welcome to my channel number 10. So there we have the problem on the screen. Find the derivative of the following. Y equals cos of 2 tan inverse of square root of 1 minus x divided by 1 plus x. Right? So this is what we have as the problem. And before we jump into applying our derivatives, I want you to take a close glance at this expression, right? So we have a tan inverse of square root of 1 minus x divided by 1 plus x, right? So I'm just going to copy that expression here. And I'm drawing your attention to one of the earlier videos where we solved for square root of 1 minus cos x divided by 1 plus cos x, right? And if you haven't taken a look at my that particular video, I'll put a link to that video in the description and kindly take a look at it. So what we have solved for as a part of the problem is this particular identity, right? So I have my 1 minus cos x divided by 1 plus cos x equals tan x by 2, right? And we're going to use this particular identity to solve the problem, right? And it's not a direct application of the formula, but an application of this particular formula after I make a particular substitution, right? And what is that substitution? That substitution is nothing but x equals cos theta, right? So when I make this substitution x equals cos theta, is it really okay to make this substitution, right? Cos theta has a range, and what is that range? -1 to +1, right? Inclusive of -1 and +1, right? So my x also in this particular function has to belong to that particular domain, right? So I need to ensure that before I make the substitution x equals cos theta. And when I have this expression 1 minus x divided by 1 plus x, right, I'm just going to rewrite this particular expression here in a slightly different manner. So I have this square root term, and I know that a term inside the square root cannot go negative, right? So which means I have 1 minus x, the whole divided by 1 plus x, right? My x when it takes, so in this particular expression, square root of 1 minus x divided by 1 plus x, I'm going to do simple rationalization, right? All I do is multiply and divide by 1 plus x, right? And let's see what do we get. My 1 plus x in the denominator becomes a 1 plus x whole square. And then I have a 1 minus x into 1 plus x, right? So this term in the denominator 1 plus x the whole square is always positive, right? I'm referring to the expression in green, and the expression in yellow 1 minus x into 1 plus x, let me highlight it in yellow, cannot take negative numbers. So if x is greater than 1, what happens? 1 minus x, right, becomes negative, right, which is not permissible here considering that we are inside the square root, right? I'm referring to this particular expression because my x is greater than 1. I have my 1 minus x becoming negative. My other expression 1 plus x, let me pick out a different color, will be positive, right? So I will have uh, a negative into positive whenever x is greater than 1. Therefore, my x greater than 1 is not possible for this particular function y, right? So that is the first point I want you to understand. And next I come to x lesser than minus 1, right? Now I'm going to put this all in black because we're discussing the second scenario here. So when x is lesser than minus 1, right, what happens? When x is lesser than minus 1, I know that my 1 plus x in the numerator, I'm just highlighting it, will take a negative value, right? And then my 1 minus x, right? When x is lesser than minus 1, I know that my x is negative and 1 minus x will always be positive. So I don't have a problem with the other expression, but still I have one negative into positive, which makes it, you know, invalid because I will have a negative number in the square root, right? Therefore, for all values x greater than 1 and x lesser than minus 1, I see that this particular function has a problem, right? And therefore, it is okay and we are fine to make the substitution x equals cos theta, right? So that's the thought process I wanted to tell you before, going ahead and putting x equals cos theta into this particular function, right? I hope you folks got a hang of this. If you've not yet got a hang of this, please do make a mention of this in the comments and I'll be happy to support you further, right? So I'm going to delete this and I'm going to put back my x equals cos theta into this particular expression, right? So when I do that, my x becomes cos theta and the expression inside square root is 1 minus cos theta divided by 1 plus cos theta, right? And now I'm going to use the identity which we highlighted above. Oh, I've not yet highlighted it. Let me highlight this particular identity. Square root of 1 minus cos x divided by 1 plus cos x equals tan x by 2, which means I can directly call this as tan theta by 2, right? So when I make the substitution x equals cos theta, my expression inside tan inverse becomes tan theta by 2, right? Now I go back to my main expression. I write my y, right? My y equals cos of 2 tan inverse of, now that we have made a particular substitution, I know that it is nothing but tan of theta by 2, right? So this is what I have, right? So my tan inverse of tan theta by 2 is nothing but theta by 2, and which means I have 2 times theta by 2, which means we are left with a y equals cos theta. This is what I have. I cancel out the 2 and I'm left with cos of theta. So now that we have y equals cos theta, I want to draw your attention to the substitution that we made. So the substitution that we made originally is x equals cos theta, right? So I have now with me y equals cos theta, which means my y equal to x, right? I'm just putting back theta in terms of x, and then my x equals cos theta was the original substitution. Therefore, now my y equals x, right? So now what is my dy by dx? My dy by dx is very simple. It's equal to 1, right? So let me highlight it in pink. So that's our final answer. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.